I am Arshad from CC department. My mini project is on refined loan approval prediction through market trends and seasonal analytics. Agenda, introduction, statement of the problem, scope of the project, methodology, outcome, result, test cases, conclusion, future work, references. Introduction. In the field of financial risk management, technology has advanced significantly, transforming how loans are evaluated and managed by incorporating sophisticated data-driven models. Loan approval prediction is a process that assesses a browser's financial status to forecast their ability to repay based on the factors such as credit history, income, and existing debts. Traditional loan approval systems often lack accuracy as they rely on static data, failing to account of real-time market fluctuations and economic changes, leading to less precise decisions. A new approach is integrating market trends and seasonal analytics, enhancing prediction accuracy by dynamically adapting to current financial conditions, improving the loan approval process. Statement of the problem. Relevance, reliance on static criteria, lack of real-time data integration, inconsistent evaluation, need for greater efficiency. Scope of the problem. We develop a machine learning model using Python to improve the accuracy of the model by integrating market trends such as interest rate, fluctuation rate, etc., along with seasonal analytics such as summer, winter, based on that. Then the targeted audience, financial institutions, loan officers in the banking sector, and users, borrowers. Deliverables, a trained and evaluated machine learning model, a user-friendly interface for the model development, comprehensive documentation detailing the model's architecture, training process, and performance. Inclusion, data from Kaggle, integrating market trends and seasonal analytics. Exclusion, loan ID will be excluded from the analytics since each individual or loan data entries has a unique loan entry that does not contribute to the prediction model. So we are removing it. Limitations, data constraints, limited availability of diverse data. Model generalization, very low generalization since the loan can be from higher ranges. Expert validation. The model's prediction will require validated by a bank officials to manage or to verify its accuracy and prediction relevances. Methodology, data collection. The dataset is sourced from Kaggle and merged with external features like interest rate, inflation rate, and seasonal data for comprehensive prediction model. Data pre-processing. Basic cleaning steps are followed by encoding categorical and numerical features, ensuring the data is properly structured for model analytics. Model development. The light VBN algorithm is used with hyperparameters tuning via grid search to improve the accuracy of the loan approval. Portal development. A Streamlit-based portal is built to allow both user and lender to input loan data and receive either approved or rejected predictions. Architectural diagram and flow. First, the data is collected from the Kaggle, then the data is sent to the pre-processing in which the numerical data and numerical and non-numerical data are characterized. Then the data is split into training data and testing data. Then the training data is given to the model for training, along with the inflation rate and interest and user data. Then, then based on the input of the user, model predicts the value. Designing use case diagram, UML diagrams. Use case diagram. A use case diagram is a graph of actors set of use cases enclosed by a system boundary communicating association between actors and users and generalizing among use cases. The use case model defines the outcome and the outside and inside of the model's behavior. Here is a simple use case diagram in which both user and lender can upload data, make predictions, and view the prediction. So, in other words, in our project, both facilitates the user and the bank officials also. Algorithms used. The project uses the following algorithm: light gradient boosting machine, Light GBM is a powerful gradient boosting algorithm that efficiently handles large data sets with high dimensional features. Idea for loan prediction tasks. It uses a leaf-wise tree growth strategy to focus on the more informative splits, improving both speed and accuracy. For example, in, in this project, Light GBM identifies key factors like income and credit score, the most impact like approval, loan approval. By focusing on critical splits, it provides faster, more precise prediction, making it efficient for real-time loan decision making. Then, grid search for hyperparameter tuning. Grid search is an automated technique used for improving the model accuracy by exploring and selecting the optimal hyperparameters for the light GBM. Hardware and software selections. The minimum requirement for a project is processor with i5 or equivalent for efficient computation, RAM 8 GB or higher. Storage should be SSD, can be more than 256 gigabytes. CPU is optional, but it will improve the performance and the runtime of the model. Software requirements: Python, Streamlit used for a built-in for user interface between the model and the front end. Google Collaboratory, cloud-based platform for collaborative coding used for data analytics, model development, and explanation. Visual Code to integrate. Uh, Sorry, it's an ideally for code development, debugging, and version control. Implementation. These are some of the libraries that are required for the implementation of the project. Panda and NumPy for data manipulation and pre-processing, LightGBM for building an optimized loan approval prediction model, and Streamlit for creating a user-friendly interface for the web portal. In this, uh, we are importing the necessary we are importing the necessary libraries and also the data set from Kaggle. So in this, the data is split into training data and testing data from the Kaggle, and this is the model design, and we are fitting the data. So we are giving the training data to fit the model. In this app.py, we are training and again testing the model. In this code, we are implementing seasonal analytics. For example, if the month is 3, 4, or 5, then it can be considered as spring. So in this form, we are categorizing the season, and we are also integrating interest rate and inflation rate for testing purpose. In this part, input is prompted from the user from the front end. So the user will give his or her annual income, loan amount, credit score, etc., etc. The output will be predicted and the results will be shown. So these are the raw output that we have taken, and the predicted value. These are some of the test cases, and the precision and accuracy and recall of the project. The model is conclusion. This project provides an accessible loan approval prediction tool that combines personal and real-time economic data for relevance and accurate assessment. The user-friendly interface and robust error handling ensures a smooth experience. By using AI, the project enhances transparency in loan decision making. It open access design without logging, broaden its usability, often quick data-driven loan eligibility check for all users. Future work. So we are trying to implement it for all over the world. So it currently works in India. So we can, based on the inflation rate and interest rate, we can make it globalized. So these are some of the references which you can go and refer. Thank you. Now let's see the model deployment. So we are deploying it using Streamlit. So Streamlit space run space app.py. So it opens a local host in Streamlit in which the user have to insert the data. But we are also planning to provide authentication and authorization to improve the accuracy of the and also the privacy of the application. So first, the number of dependencies can be Then the education can be 0 or 1. Here 0 1 refers to yes or no. And since the annual income should be given in lakhs or in crores, because the data set is not diverse, so we have managed to do this. Then loan amount and number of years, credit score. These are the data should be inserted by the user. And it is the current interest rate and current inflation rate which we get from the API, external API. And once the predict button is clicked, the whether the application is predict or not. So here the application is rejected. It is because the interest rate and both the inflation rate is high. So the and also the credit score and loan amount is also high, so it got rejected.